Let's see this binomial. Z plus 7 times Z minus 4. Right, what do? We do Z times Z. This is Z squared. We do Z times negative 4, which is negative 4Z. Right, maybe I split this into. So Z times Z, maybe I do one more step. I think there's a double distribution, then plus right. So I have Z times the second parenthesis, I have a plus 7 times the second parenthesis. Then when I do that, I get a Z squared and minus 4Z. Okay. The second one, I get 7Z. Then negative 4 times 7, that's negative 28. So now I see the middle two terms are like terms. I can combine them. Negative 4Z plus 7Z, that's positive 3Z. So this is how we FOIL, people call FOIL, or double distribution, multiplying two binomials. Well, let's see this example. What's the difference between this one from the first one? The first one will have Z minus 4, and this one will have 4 minus Z. Well, 4 minus Z is negative Z minus 4. Okay. So according to the previous, right, so we could write like this: negative Z plus 7 times Z minus 4. And then we know Z plus 7, Z minus 4, which is the above, which is put a negative, oh, here. Z squared plus 3Z minus 28. Right, we just have to have this negative sign in front of it. So then we get negative Z squared minus 3Z plus 28. Anyone has any questions? Some binomials are very special. Let's see those two binomials. So this one is B minus 3. This one is B plus 3. So this is negative 3. This is positive 3. And we call these conjugates. So those two binomials conjugating with each other, conjugates of each other. And then when we multiply, if we do step by step, let's do step by step first. We do B times B plus 3 minus 3. Remember double distribution? B plus 3, double distribution, right? Then we get B squared. Let's just borrow this one. I get B squared plus 3B minus 3B, then minus 9. Then the two middle terms can be simplified. Plus 3B minus 3B, that's a 0. So I get B squared minus 9. And this is so special, it gets a name. It's called difference of two squares. So I have this formula. Difference of two squares is first one plus second one times the first one minus the second one. Okay. So this is called difference of two squares. You could think of B minus 4, B plus 4, that would be B squared minus 16. B minus 5 times B plus 5, that would be B squared minus 25. B minus 10 times B plus 10, that would be B squared minus 100. Right? So if the two binomials are conjugates of each other, it's called difference of squares. It's just the first one square subtract the second one square. Well, see this one. This one is different. This one will have b minus 3 times b minus 3. So those two factors are the same. Those two binomials are exactly the same. So usually we put together as b minus 3 raised by 2. Same as if we have x times x, we would rather write x squared. So this is perfect square. Just make sure you see the difference. You see difference of two squares and the perfect squares. Perfect squares, the square is outside the parentheses. And when we expand that will get the first one square plus 2 times the first one and the second one. Right? First one times the second one will get negative 3b. Then we multiply by 2. So get negative 6b. The negative 3 squared is positive 9. So we'll also get 3 terms. And then the formula is a plus b squared equals a squared plus 3ab plus b squared. So make sure gradually you remember those formulas. So important. Okay. If it's a minus b squared, that equals a squared minus 2ab plus b squared. Well, let's see this one. We have ab squared plus 4, ab squared minus 4. We recognize this is the difference of two squares, right? Because it's plus 4 minus 4, and the first term are the same. So by the formula, that just equals the first term to be squared minus the second term to be squared. Well, 4 squared equals 16. That's the easy part. So how do we square this one? A squared, because everything is under square in the parentheses. So we need to square everybody inside the parentheses. So we got a squared. And b squared raised by 2, that's b raised by 4. So we got a squared, b raised by 4 minus 16. Anyone has any question? Let's see next example. 5k cubed, 5k cubed, plus 2m squared minus 2m squared, conjugates. Right? So what do we get? We get the first one square subtracting the second one square. First one square, we have 5 squared 25, k raised by 3 times 2, 6. So 25k raised by 6. Then minus the second one square. Second one is 2m squared, or 2 squared is 4. M squared is m to the 4th power. Right? Difference of two squares. Anyone has any question? Okay, let's see one involve fractions. Well, b squared over 7 plus y, b squared over 7 minus y. The first term are the same, the second term are opposite. One is plus, one is minus, so they are conjugates. So what do? We know the difference of two squares. So we square the first one, b squared is b raised by 4. 7 squared is 49, then minus y squared. Okay, difference of two squares is a very useful property. If you do 1 million square, subtract 999 square, you can break into plus minus conjugates, right? You do 1 million plus 999,999. And 1,000 minus 999,999. Right? 1 million minus 999,999. Right? That's just 1. That's just 1. So the first parenthesis adds up to 1,999,999 times 1. Right? It's very useful. So difference of two squares, can be seen everywhere. So how do we multiply polynomial by polynomial? Let's see, we did a monomial, we did a binomial. Now let's see a binomial with a trinomial. Trinomial means we have 3 terms. We do the same thing. Right? We distribute 9z as a common factor. We distribute -1. Then we just multiply 9z to 6z squared. We get 54z cubed. 9z minus 4z. Well, -4 times 9, -36. Z times z squared. Then negative 10 times 9z, that's negative 30z. Right? Then the second part is -1, right? -1. So -1 just changing every atom inside to be the opposite. So positive 6z squared now becomes negative. Negative now becomes positive. And positive now, negative become positive. Then we combine like terms. 54z cubed has no like terms. But negative 36z plus negative 36z squared minus 6z squared, that's minus 42z squared. Right. Negative 30z plus 4z, that's negative 86z. Then plus 10, plus a constant. Anyone has any question? Or let's say a trinomial times a trinomial. We do triple distribution. We use the first one in the first parenthesis, multiply second parenthesis. Then plus az, second term, multiplied by the second trinomial. Then minus 3 multiplied by the second trinomial. Now we just have to multiply this monomial with the trinomial, each one of it. We get this. And for this one, we get this one. So we combine like terms. Once like term, we have z cubed, negative 10z cubed plus 64z cubed. That becomes plus 54z cubed. 20z squared minus 8 squared minus 24z squared. That becomes negative 12z squared. Then 3z minus 6, right? No, 16z and 3z, which is 19z, then minus 6. So combine like terms when we add or subtract. Any questions? Let's see next one. Trinomial again. Yeah, Ajeda?
Professor, can you hear me?
Yes, I can hear you.
Okay. Hello, good afternoon. A question
Yeah, good afternoon.
I have is, when you're multiplying the monomial against the polynomials that has a variable, if any of the monomials in the polynomial also has a variable, those variables just combine, correct?
You combine the same base. Let's see here. If we do 10z squared times az squared, we multiply number with a number. We're looking for the same base. So this base is z, this base is z. So we just, how do we multiply them? We just get z raised by 2 plus 2. We add up their exponents, which is z to the fourth power. Does this make sense?
Understood. I meant as in, like, if the 10z squared was multiplied by 8x squared, for example.
Okay, that would be 80x squared z squared. Because different base, we cannot combine them. We cannot add the exponents.
Thank you.
You're welcome. Let's see this one. So we have three trinomial, multiply by trinomial. We do the same thing, triple distribution, right? Triple distribution. The only thing annoying is the calculation, right? You just have to calculate every term multiplying by the monomial multiplied by the three terms inside the parentheses. Then once you finish multiplying them, you look for like terms to combine. So come back to perfect square. Such important. Okay, everyone remember the formula. What's the formula? The formula is square the first term. So we have two terms, right? First term, second term. If we get a perfect square, we square the first term, we square the second term. Then we multiply those two, we double it. We double the product of those two. A squared plus 2ab plus b squared. So let's follow that. So a is 2x here, b is 1. So according to this formula, we square the first one. 2x squared becomes 4x squared. Then plus second one squared, 1 squared is 1. Then plus the product, right? Double the product of those two. Well, 2x times 1 is 2x. 2x times 2, 4x. Okay. Well, now let's see minus, right? So square the first one, we get 4x squared. Square the second one, well, what's negative 1 squared? Still positive, right? But now the two terms becomes 2x, a is 2x, b is negative 1. So the product is negative 2x, right? Negative 2x. Then we double negative 2x, we get negative 4x. Right. So if I write one more, I'm going to write the minus. Remember, minus is actually, so what is minus? A minus is a plus negative term, right? Just means b term is negative. So this here we get negative. Okay. But the b negative b squared is still positive b squared. Also try to remember difference of two squares. A squared minus b squared equals to a plus b times a minus b. Okay, so we learned two formulas today. Okay, this is called difference of two squares. Okay. You have a squared minus b squared that can be factored as a plus b times a minus b. So difference of two squares, perfect squares. Okay, let's try to remember them. It's very important to remember them because You'll use it all the time. You need this property all the time. So a minus b squared, right, is a plus negative b squared, is a squared minus 2ab plus b squared. For 3x squared minus 2 squared, we just square the first one, square the second one. Well, what is the second one? Second one actually negative 2 squared. But negative 2 squared is still positive 4, right? And add the middle one. So double the product of those two terms. If we simplify it, we get 9x divided by 4 minus 12x squared plus 4. Anyone has any question? Okay. Conjugate pairs, we call this a minus b, a plus b conjugate pairs, because that's just alpha by sign. Let's see here, 5h plus 3, 5h minus 3. Right? We recognize this is the difference of two squares, which equals the first term square, 5h squared, which is 25h squared, minus the second term square, minus 3 squared, which is 9. Again, go back to the previous one. We have one similar one, 1,000 squared minus 999 squared. That's 1,000 plus 999 times 1,000 minus 999, which equals to 1,999. Because the first one, 1,000 plus 999 is 1,999. But the 1,000 minus 999 is just 1. All right, just 1. So this is one of the cubed part. Let's see this one. 7 plus 2x times 7 minus 2x. Right? We just get a 7 squared minus 2x squared. Well, 7 squared is 49. Minus 2x squared, which is 4x squared. Here we have y plus b squared over 3, y minus b squared over 3. Conjugate pairs, right? Difference of two squares. That's just equal to y squared minus y squared minus b squared over 3 squared is b to the 4th over 9, right? Minus b raised by 4 divided by 9. Okay, multiplying polynomial functions, right? Let's see here we have an example. One function is quadratic, another function is linear. And we can multiply those two functions. When we multiply, we just FOIL, because each one is binomial in this case. X squared times negative 3x, that's negative 3x cubed. Then x squared multiplied by negative 5, we get negative 5x squared. Then let me just write one more step here, actually. First we get, I'm going to copy paste this. So x squared times negative 3x, that's negative 3x cubed. Okay. Then x squared times negative 5, that's negative 5x squared. It is this notation. That x squared times negative 5 is negative 5 squared. Then minus 2x times negative 3x. That's negative 6x squared. Right? Then 2x times negative 5. That's negative 10x. wrote down the intermediate step. So now negative 5x squared and negative 6x squared are like terms. So we can combine those two terms to get negative 11x squared. So that's it. So when we multiply those two functions, we get a degree 3 polynomial. Let's change this. It doesn't look as nice. Then, well, of course, we can evaluate, right, at any x given value. So if we multiply f and g two functions, so we want to evaluate at a 3, we just plug in 3 for x value. Then we, do the calculation, get a number. Anyone has any questions? Just exactly same as multiplying polynomials, right? Let's see this one example. We have 6 minus 2x squared, 6 plus 2x squared. Difference of two squares again. We just square the first one, 6 squared, 36. 2x squared, 2 squared is 4, x squared is x raised by 4. Then we can evaluate at negative 2. Then just plug in x for negative 2. Let's solve it. Just get a number, right? Get a number out. Let's see this word problem. The word problem is the width of a box is 5 feet more than twice its height. What? Let's call the edge to be the height. Right? We want to express the width in terms of the height. So that means we need to write down h in equals to something. Oh no, width, the width, width. Width equals to some h plus some number. So twice its height is 2h. 5 feet more, that means add 5. So that means the width, if we use w, width equals to twice of the height plus 5, so 2h plus 5. Anyone has any question? Let's see this one. The length of the same box is 3 feet less than 5 times its height. So now we want to find the length. Right? 3 feet less than what? 5 times its height. 5 times its height is 5h. 3 feet less is minus 3. So that's length. So I have width, I have length. Maybe we use L to represent. L equals to this. Then we want to find the area of the base of the box. This only thing express width in terms of its height. If we want to find the area of the base of the box, no, it's width times length, right? Of course. The area can be expressed as length, which is 2h plus 5. Width times its width, right? 5h minus 3 times its length. And if we want to expand, we do 2h times 5h, we get 10h squared. Then we'll have 5h times 3, negative 3 and negative 6. Then 5 times 5h, 25h, 25h minus 16h. 25h minus 6h, that's 19h, positive 19h, right? So negative 6 plus 25, that's positive 19. If we want to find the volume of the box, so we do 3-dimensional product. Length times width times height. In this case, we call the height h. So the area is width times length times height. and which means we can use the above calculation multiplied by h. So we get 10h cubed plus 19h squared minus 15h. Anyone has any questions? Okay, let's see example 2. Sarah throws a ball off the top of a slide in a park. The ball's height in feet after t seconds is given by the function downward parabola, right? Whenever we toss something towards a ball, the trajectory of the ball is a downward parabola. It's a polynomial of degree 2, or it's a quadratic function. What are the variables? Well, the variables are t and h of t, right? T representing time, h representing the height of the ball. What does each one represent in this problem? T represents the time passing in seconds. H of t represents the height in feet of the ball after t seconds. What is the height at 1 second, at 4 seconds? We just have to evaluate, right? H of 1, so changing t to be 1, to get 19. We plug in 4 for t. We do the calculation. We get negative 156. Well, what does it mean, negative height? We don't measure height negatively, right? When it reaches the ground, the floor is just 0. So instead of saying negative 156, just say h of 4 is 0, right? Because this is application. This is a live application. We don't do negative measurements. Negative measurements means, you know, the ball hits the ground seconds ago. Okay, anyone has any questions? All right, so this is a little something. See, okay, to remember the perfect square, right? Let's remember if we have 16 square, right? We do not want to use calculator. So what do? We can split it into 10 plus 6, then read by square, binomial square, perfect square. Perfect square is square the first one, square the second one, multiply those two, double it. So second question, from what height did Sarah throw the ball? Well, from what height? The original height, right? Which means t equals 0, because she hasn't tossed the ball yet. So that means t equals 0, 0, the first two terms disappear, just equals 10. Okay, anyone has any questions? That's all for today. That's all for today, talking about multiplying polynomials and multiplying two polynomial functions. Anyone has any questions regarding this material? Oh, that's fine. Yeah, I just see the comments in the chat. Okay, I want to show you something on my open math. So exam 1 is done. Oh, I haven't opened it. Sorry, hold on one sec. Let me open my open math. So some of you, I hope no one gets in trouble, because I just learned this trick. Let me see if anyone. Oh, okay, that's fine. That's fine. I know sometimes we have internet problem. We are in and out. That's fine. So I want to show you on my open math, right? Because the department chair asked every instructor to do this. So if I go to gradebook, I'm going to just randomly choose one. I'm going to just, let's see. So this is 2021, okay. Let's see if I go to these students. Then I go to, no, I should go to gradebook, I think. Oh, here, right here. You see, login log, activity. This is activity log. I just learned. This activity shows one of these things. When you take exam, remember first you have to sign your affidavit, saying you promise not using any outside material. You sign your name, right? How would a teacher know? You know, you do not obey that by checking this activity log. This activity log will show what did you do in the period of time. Let's see, in this case, this is my 2021 class. Because this is all about homework. Let's see for exams. So, you know, he's looking for help for exams, for homework. So that's fine. When you do your homework, you can find any possible resource to help you. But you're not supposed to consult with any resource when you take exam. So these students, right, didn't do anything wrong. Let me see. Let's see if you can possibly find something. Right, so this has exam 1, exam 2, 4, right? Let's check this person. You see this consultant is all for homework, 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 homework. Yeah, this student did a while also. So the department chair is asking instructors to do this, to check to see if there's anyone. I don't want to show you. I don't want to show you because I have checked already. To see if anyone during the exam time, you know, the activity log has recorded someone went to some other website to look for help, and which website, which resource the activity log shows. All right, already find this. So if you know, and also the department chair will check himself also. I don't know what's the consequences yet, but I didn't know this before. Otherwise, I would tell you beforehand. But for exam 2, for later exams, remember this. Do not consult with any websites. Okay, the system will make a record of that. Let's see. When exam grade going to be released? It is released. Yeah, only a couple of you have some problem. But for most of you, the grades are there on my open math. Because if I open it, I'll see. Let me see. If I open it, I don't want to share with you because you are able to see others grades. It is there. I don't know how you see.
Sorry to ask, but did you already post the grades?
Oh, I did not post it on Blackboard. It's on my open math.
Oh, because I don't see mine. Mine says NA.
Oh, it only give you A, doesn't give you the grade. Oh, I see.
No, it just says NA as in not available.
Oh, really?
Yeah, and also I had a question for the pre-exam quiz. Like, do you have to go back in and grade that too? Because I think we had to submit work for that one, and I didn't get anything updated for that either.
Right, that one is not updated. Oh, maybe I have to do this show all. Check now to see. Let me refresh my page.
All right.
I have one of the buttons saying hide all. Now show all. I'm not sure if you, this is show locked. Oh, that's for me, I think. Right, check to see if you can see now. If not, I'm going to report to the coordinator, which is the department chair. Maybe he has to do something.
Yeah, I still can't see anything, Professor.
You still can see it? Okay. I'm going to have to ask.
Okay, and also, the pre-exam quiz, I'm pretty sure we had to upload work for that one, and I got like an automatic grade, and it said that I remember.
Hold on. Which one you're talking about?
I'm talking about, give me 1 second. I'll tell you. I'm talking about the pre-exam quiz. It says spring 2023. That was due on February 24th.
Oh, okay. I'm looking for this. I have final exam, homework 10%, instructor specific.
My
quiz
pre-exam is also 55, so I think it's because like the work that we submitted wasn't graded.
Instructor specific 100 points. Final exam practice. Chapter 1 homework review problems. Chapter 2 review problems. Chapter 3, Chapter 4, Chapter 5. Oh, here, I see it. Exam 1 practice problems. I see that. Yeah.
No, not the exam 1 practice problems, Professor.
No.
Exam quiz. So it's on my screen. It's right under the spring 2023 syllabus quiz. I don't know if it's the same for anyone else, but mine is right under that.
Oh, quiz. Quiz 10%. Okay. So I think he puts every quiz under the same one, because I don't see quiz 1, quiz 2, or quiz 3. Just a quiz. If I expand, let me expand this.
I'm talking about, so we had to take a quiz on February 24th, and it's titled pre-exam quiz, where we had to attach work for certain problems. My grade got updated, so like on my screen, what I'm trying to say is that it's coming under, so like where you see instructor specific, right under mine shows spring 2023.
Okay, can you share your, let me make you a presenter so you can share your screen with me so I know exactly what's going on.
Okay.
People talking have no idea. Okay. Now you're presenter, you can share your screen with us.
Okay, let me see if I know how to do that.
Okay, if the grade is not going up, I have to ask him.
Oh, share content. Can everyone see my screen?
Yeah.
Yeah. So I'm talking about this one right here, Professor. Right here. So that one has stayed 55, and I'm pretty sure we had to submit work that had to be graded, and it hasn't been updated at all.
Pre-exam quiz. Okay, let me look for my end. Pre-exam quiz. Pre-exam quiz. That's pre-exam 1 quiz, right?
Yes.
Pre-exam quiz. Oh, yes, I see it. Yeah, I see it. Okay. Yeah. Yeah, I haven't done anything with that yet. But the highest one is 5.5. The lowest one is nothing. And some of you get 4, some of you get 5. And yeah, I haven't done anything with that yet.
Okay, I just wanted to make sure. Thank you, Professor.
Yeah. You're welcome. Yeah, you can still submit after. Oh, okay. If we attach what we're doing it, let's still be okay. Yeah, Ajeda.
Professor,
Yes.
so in the exam, it's had a little text box where you can type in the work that you're doing throughout, but then at
Yeah.
the end, it also asks you to attach work. So is it saying that all of the typed responses should have been submitted at the very end of the exam, or
Yeah, you know,
okay,
I know,
text
but
during the exam?
I think I know what you're talking about. Yes, because some of you send me the email saying, you know, I already submitted the work, but it asked me again. I don't know what's going on. This did not happen in the previous semesters. But however, once you submitted, everything's here. So I checked for a couple of students, so there's no problem. Yeah, I didn't attach only during. Okay, let me share my screen with you about attaching. So let me go to those one of this practice. Okay, let's go to this one because this is fall 2021. Am I sharing with you or no? Okay, so basically you have two choices, right? Either you type in here, you type your work here. Then, or you attach, right? You read on a piece of paper, you took a picture, you save to your computer, you attach here. Yeah. You choose file, you upload. Because two ways of doing this. You don't have to do both ways. You just pick one. But I figure type is much easier here, right? I don't know. It really depends on everyone's situation. All right. Any other questions? I'm just not able to share the whole screen with you about your grades. But I can give you some statistics. Let me see. Term exams, collapse. Okay, exam one. This under this. Exam one practice problems. It's so complicated. Let me see. Where do I find? So I expanded again. Next exam one practice. I need exam one grades. Where are you? Oh, right here. Okay. So out of 100 points, I think the highest one is 96 or 98. The highest one, 96.8. It's about, 98 actually. The highest one is 98. The lowest one, except some people are not able to do it. Well, for a couple of you, I haven't given you grades yet. The lowest one, I see 22, 23.1, 27.1. I would say 19.7 is the lowest one. So I don't know what's going on. You know, if your grade is under 75, that's kind of dangerous for this class, for passing this class. If you don't see your grades, I can ask him, or let me see, this is saying show locked. That's saying show all. Why you don't see your grades? I'll ask the coordinator again, okay, to see how you can see your grades, okay? Any other questions? Just worry about the grade. Let me see. So how? Oh, your grade is pretty good, but let me see your activity log. You're gonna get yourself in trouble. Because you click on help when you do when you're taking exams. I don't know the consequences yet, because the consequences are due to the department chair, you know, who happens to be the coordinator of this course. But this activity log saying you clicked for help, you clicked help for those questions. It has some records here, recorded here. Our day of final is May 19th. May 19th. But I don't get the date yet. I don't have the room and time yet. All right. Once I have those information, I'll post on Blackboard. But you know what? Exam 1 is done. So I don't think you should worry about exam 1 now, because it's passed. You know, even you worry, you're not going to do any good about it, right? So just keep studying, and your final will be more important, and also next exam will be important for you, more important for you. Then something has passed. Our day of final, I think is May 19th, but I do not have the final dates, time, and room yet. So I don't think you should worry about that. I think you know, just to do homework. If you miss the class, make sure you watch the recordings. If you have questions, make sure you ask me. I can explain more. So focus on studying the material. okay? So forget about exam 1 now. It's past, it's past. Will be a study guide for the final, exactly same as exam 1. Every exam, you will get practice questions or pre-exam practice or something like that. All right. So if we go to, I really think everyone should do well for this course. You know why? Because the coordinated structure, this is so well. Everything's here, right? Everything is here. Class material, you see, every exam, before exam, you get exam practice. You know, how nice is that? Exams and homework. Oops, that's something else. Pre-exam quiz, practice problems. You know, you have all this, right, to help you to succeed every exam. You know, after exam, you're worrying about your exam. That doesn't make sense. Oh, I can see your work, of course. But you cannot see your work. I don't know why. So I'm going to ask him to see why students cannot see their grades. Okay. Let me see if I change my student view. This is possible. No, because I'm your instructor, so I can see your grades. I don't know why you cannot see. No, that's not the reason, Randomly, the reason I was talking about the activity log, okay? The department chair sent an email asking instructors to check. Oh, I'm not supposed to show you this. To check activity log, I can go back to, right? There's something called activity log. Okay, see here? Nothing for this one. Yeah, see here, activity log, right? It records where do you search for help. For homework, it's okay. You can search for help, right? For practice, for quiz, for homework, you can search for help. But you cannot search for help when you take exam because you have signed, you have promised not to do that. So if you did that, you're gonna get yourself in trouble. I don't know the consequences yet, okay? Because the department chair will check himself. I just learned this. I didn't even know this last semester. Oh, you didn't have anything open. You don't have to worry about. If you don't have, if you didn't look for help, you didn't search on any other website, the activity log shows nothing. So you have nothing to worry about. Okay. This is something new. I just learned as well. Okay, anyone has any other questions? Again, like I said, you know, doesn't matter what you did, doesn't matter how good or how bad you did for exam 1, it's past, let it pass. Focus on the future, okay? Focus on now, focus on future, all right? Any other questions? Oh, you're welcome. You're welcome. Just don't worry about what's, you know, whatever is in the past. Leave it in the past. And yeah, it's done. It's done. Let it be done. So focus on your homework now. Focus on your future, next exams, and your final. Okay. I'm trying to see. Okay, any other questions? Yes, David. Have you taken the exam?
I have not been able to take the exam yet because it just won't open for me. It says
Oh,
it's
it did
still
not?
closed.
Oh, I see. Then just forget about that, I guess. Because let me check my email. Because 3 students had a problem. I did ask him. He opened for all of you until. Oh, hold on. Today's what? Today's Monday, right?
Today's Tuesday.
Or today's Tuesday. He says until Tuesday. Let me see what time exam 1. Yeah, for you. And you and the other 2. Da, 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 da. Yeah, he did a reply. He did a reply saying, let's see. Hold on, that's between you and me. There's another one between me and him. Oh, right here. Oh no, this is something else. Oh, here. The students, 3 students. Were you the one being locked out, or you have some internet problem?
I was locked out.
You were locked out. Okay, so he has done for 3 people. Okay, I'm gonna ask him again. All right.
Okay.
He's saying. I remember he's saying right. He opened it for all of you. I don't know why you didn't. Let me just send him an email right now. Reply. What is our class code? TY4B. TY4B. Let me see. David Martinez. Yeah, I see from my end, I see you're not being blocked out, but your exam is not open. Okay, I sent him an email to see what's once he replied to me, see it's open for you. I'll send you an email. Okay.
Okay. Thank you so much, Professor.
You're welcome. Okay, let me see the chat. All right. All right, if you have no question, you're a free bird. Go ahead and do your homework, right? If you do, I'm here to talk to you. Oh, let me stop recording.